Working with continuous compound interest is not too vastly different than working with other compound frequencies. As we know, the only major difference is that we are compounding infinitely, and that is why we use the base E in our formula. So looking at example 1, if you deposit $1,000 at 4.3% interest, remember this is APR, compounded continuously, what would your ending balance be to the nearest cent after 5 years? So we always want to define our parameters along with our variables. So 4.3% is R, and remember we would want to write that as 0.043. 1,000 is our principal, so that's the value of the parameter P. And our value of T is 5, and we're looking for the balance after those 5 years. So we take 1,000 times the natural number E raised to the 0.043 times 5. If you have a scientific calculator, go ahead and try typing that in, because there is a very specific way you will need to type that. And if you end up getting the same final answer as I, then you know you typed it incorrectly. So your final answer should have been $1,239.86. In example 2, this example more so goes over the way to use a calculator as a tool for calculating continuous compound interest. So here we see that Ed computes the ending balance for an account he's considering. The principal is $20,000 and the interest rate is 5.39%, compounded continuously for 4 years. The keystrokes he entered into his calculator are as follows. When he pressed enter to get his final answer, he got $84,430. Now, this raised a red flag because 20,000 turning into 84,000 in only 4 years seems a bit suspicious. So we want to figure out, how did he type this into the calculator improperly? So the correct balance should actually be $24,812.12. So if you have a scientific calculator, go ahead and try typing that in so that your answer matches mine. And from there, think about, how did what you typed in differ from what Ed originally typed? So go ahead and pause the video to try that out, and then press play once you've got an idea. So Ed's mistake was in how he entered in the exponent. He made this 2 set of separate parentheses when in reality he should have just typed 20,000 E and then 0.0539 times, so use the multiplication button, 4. So now the calculator recognizes this as one exponent, whereas up here, it actually calculated this quantity and only raised E to this power, and then took that result and multiplied it by 4. So that makes a huge difference in this case. In example 3, we are just taking the time to identify the significance between simple interest and different compound frequencies and comparing that to compounding continuously. So first, we want to find the interest if this account is computed using simple interest. So we have to recognize the principal is 2,000. The rate is 4%, or 0.04, and T is 3 years. So simple interest is I equals PRT. So filling in those values, we get 2,000 times 0.04 times 3. And that gives us an interest of $240. Now, for these next 7 questions or parts, the formula is going to look the exact same. The only thing that will change is the compound frequency. So if we identify the compound frequency for each one, that's the only value that will alter our interest. So first I'm just going through and identifying those compound frequencies. I believe there are 8,760 hours in a year. There are 525,600 minutes in a year. All right, and then we can take the time to write out the formulas. So if you need to, go ahead and pause the video to check that your formulas are the same as mine. But again, in each one of these 7, the only thing that's changing is the value of N, which is your compound frequency. But notice the closer we get to compounding continuously, the less change there is in the total amount of interest. Now, had we used a longer time period than 3 years, or had we had a larger principal than 2,000, we would see more significant changes among these 3 different types of compounding. But once you get so far into it, the differences lie in these decimal places past the 100th decimal place. But since we're dealing with money, we only worry about up to the 2nd decimal, obviously. So at this point, you can go ahead and start working on the application questions, finishing them for Unit 2.